आपकी बात मान के चुपचाप घर में बैठे हुए हैं।
क्या क्या बात है, क्या बात है। घर में रहना है सर, नाजुक लम्हे हैं।
नाजुक है जमाना, संभल संभल कर रहना,
राइट,
जब
यस।
तक ना हो जरूरी,
जब
तो
तक ना
घर
हो
से
तो
बाहर
जरूरी,
ना निकलना, पर
घर के
वेबिनार में
बाहर
जरूर आना। ठीक है ना?
निकलना।
हाँ, ये हो गया। और कुछ बढ़िया है।
Vijay Anand sir, our expert for the session, has already joined us. Good evening, sir. Welcome to the webinar.
Thanks, Ritika.
Sir, just a minute. We will be giving
Vijay,
you
good
the
evening.
rights.
Yeah, Ritika, sure.
गुड इवनिंग विजय जी।
Good evening, sir. How are you, sir?
कैसे हैं सब? बढ़िया।
After a long time.
Manish sir, can we make Vijay sir the presenter? Sir, you now have the presentation rights. So you may share and you may check it for once.
Yeah, 1 second. So you could see my screen, Dr. Ritika?
Yes, sir.
Sure, thanks. Sir, good evening. I think your voice in between got disconnected, sir. Hello?
Yeah.
We are able
Good
to
evening,
hear.
Mr. Vijay.
Yeah.
You are audible.
Yeah, okay,
Yeah,
sir. I
I
think
can
your
Please
voice.
increase little bit, volume little bit, that will be better.
Okay. Is it better now?
Yeah, it's
Yes, sir,
better.
perfectly.
Okay, thanks.
So a very good evening, all dear participants. I welcome you all to today's webinar on Industry 4.0 Trends and Challenges. Our expert for this webinar, Mr. Vijay Anand, Chief IoT Architect, Cape Gemini, Chennai, is already there with us. As per schedule, we shall be starting with the session sharp at 6 p.m. within a few minutes from now. So I request all the participants who have joined us right now, kindly ensure whatever device you are connected with through for today's webinar, you should be able to access the chat window on the same. The chat window will be an important mechanism through which we shall be communicating in this webinar. So dear participants, kindly ensure that you can access the chat window through your device. This webinar shall also be live streamed on our own YouTube channel, BVI Camp New Delhi, for knowledge sharing purposes. So any of your friends, etc., who plan to join us for this webinar through our YouTube channel, kindly inform them the YouTube channel is only for knowledge dissemination purposes. So at the end of the webinar, no feedback link shall be shared on the same. The feedback link shall only be shared with the participants who join us through our WebEx room. So dear participants, kindly ask all your friends, etc., to join us through the WebEx room as soon as possible, because soon we are going to start with the webinar. Yes, Vijay sir, we can see your slides. So a few minutes from now, we shall be starting with today's webinar, which is on Industry 4.0 Trends and Challenges. Industry 4.0, I would say it's a revolution that is not just transforming our industry and the industrial production means, but it is also affecting all other domains and spheres are being affected by this particular trend. So we'll come to know about this trend, what it holds, what are the future challenges through Sir today. I again request all my participants kindly ensure whatever device you are connected with us through for today's webinar, you should be able to access the chat window on the same, because the chat window is going to be an important mechanism through which we shall be communicating for today's webinar. Any questions you have from the expert, you can communicate the same in the chat window. I shall be facilitating you by asking them to our expert at the end of the session. And feedback link for your certificate of participation generation for today's session will also be shared on the chat window at the end of the session. So dear participants, whatever device you are connected with us through for today's webinar, kindly ensure that the chat window is accessible to you. We have a number of webinars planned every week, generally on Saturdays. Our next webinar is planned on 4th of December, and the details of that are available on our website, www.bvicam.in. I have already shared the details in the chat window. So I request all the participants kindly access that and register yourself for our next webinars also. Few more minutes and we shall be beginning with today's webinar. I request all participants, any of your colleagues, etc., who plan to join us, you can request them to quickly join the room. A very warm welcome to all the participants. I can see participants from all across India and abroad have joined us for today's webinar. Thank you, dear participants, for always joining us and supporting us in this knowledge dissemination mission of ours. It's wonderful to welcome participants from all across the country. In a few minutes from now, we shall be beginning with today's webinar. I request all the participants who have just joined us, kindly ensure whatever device you are connected with through for today's webinar, you should be able to access the chat window on the same, because the chat window is going to be an important mechanism through which we shall be communicating for today's webinar. Any questions you have from the speaker of today's session, you can keep sharing on the chat window. And feedback link for your certificate of participation generation shall also be shared on the same chat window. Good evening, Subrata sir. Welcome to the webinar.
Subrata sir is on mute.
Yes, sir.
Yes. Now I am on mute.
Good evening, sir. Good evening.
Good evening to everybody. Anyway, there are other signals and signs. So far as lip movement is there, so we can understand and try to read also.
Yes.
Maybe
Right,
without artificial intelligence.
Yes.
Correct. So, Dr. Ritika, we should start.
Okay, sir.
Oh, 3 minutes are left or what?
Sir, 2 minutes are left.
Oh, so
2
we'll
minutes.
start on time, right? After 2 minutes. My watch is moving forward.
Yes, sir. A very good evening, all distinguished panelists and participants. I warmly welcome you all to today's webinar on Industry 4.0 Trends and Challenges. As per schedule, we shall be starting with the webinar sharp at 6 p.m. Our expert for today's webinar, Mr. Vijay Anand, Chief IoT Architect, Cape Gemini, Chennai, has already joined us on board. So just within a few seconds now, we shall be beginning with today's webinar. So with your permission, can we start?
Yeah, please start.
Thank you, sir. A very good evening to all distinguished panelists and participants. Bharati Vidyapeeth's Institute of Computer Applications and Management, BVI-CAM, in association with Computer Science Chapter of IEEE Delhi Section, Consultants Network Affinity CNA Group of IEEE Delhi Section, Life Member Affinity LMA Group of IEEE Delhi Section, Inter-Society Relations IRS Standing Committee of IEEE Delhi Section, Industry Relations and Site Standing Committee of IEEE Delhi Section, with the Associations of Computer Society of India, CSI, SAFA Society, ISTE Delhi Section, and IETE Delhi Center, welcomes you all to this webinar on Industry 4.0 Trends and Challenges. Inga Bale stated that for many people, the smartphone is the first and the only computer that they have. This quote indicates not just the arrival, but the growth of a revolution, what is normally called the fourth industrial revolution or the Industry 4.0. This webinar today is aimed to discuss a high-level overview of Industry 4.0 and the related use cases and design techniques for the smart factory ecosystem. The webinar also aims to deliberate in detail important concepts like digital transformation, leading corporations, emerging 5G and Industry 4.0, etc., their characteristics and related applications. With this webinar, the participants will get to understand about the digital transformation, killer use cases considered for various manufacturing plants, the related technologies, the hardware platforms, and the various challenges that need to be considered during the design or implementation stage. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome Professor Subrata Mukhopadhyay, Chairperson, Consultants Network Affinity, CNA Group, and former Chairperson of IEEE Delhi Section. I warmly welcome Sir, and I would now request Sir to commence the session with his welcome address.
Thank you, Ritika. We have all assembled today to listen to Mr. Vijay Anand on the webinar on Industry 4.0 trends and challenges. We had earlier also opportunity to listen to him for some other topic, and as well as on this topic from some other speakers. So today's webinar is definitely very timely and contemporary topic. In fact, over the passage of time, humanity has seen industrial revolution, one after another in different form. If you go back to history, the first industrial revolution came during 1700s, late 1700s, or the 18th century and the early 19th century, with the advent of mechanization, steam power, and water power. Not that people were not knowing about the water power, because history says something else also, but steam power is definitely at that time first utilized for engineering purposes. This was followed by the second industrial revolution, which evolved around mass production and assembly lines using electricity. After Thomas Alva Edison and Nikola Tesla made them applicable for engineering. Physics was known from Faraday's days. So came early part of 20th century and more of application. Third industrial revolution came with 1950s with electronics, IT systems, and automation, which led ultimately culminating to the fourth industrial revolution in recent times that is associated with various concepts and terms, out of which some of the important ones I will be just mentioning in addition to what Ritika mentioned. Enterprises, resource planning, ERP, Internet of Things, Industrial Internet of Things, Big Data, Artificial Intelligence, AI, Machine to Machine, Digitalization, Smart Factory, Machine Learning, Cloud Computing, Real-Time Data Processing, Ecosystem, Cyber Physical Systems, and of course the 5G, or maybe we do not know, we had arranged also one day something for 6G also. So in other words, really speaking, transformation from automation to autonomous is the main mantra of Industry 4.0, as one can say and visualize for smart manufacturing. Manufacturing is not limited to, I think, physical manufacturing. There may be so many things covered under this. So anyway, let us hear further from the speaker of the day, much more details about the trends, challenges, and where we stand now and what is the roadmap for future. With this, I hand over to Ritika.
Thank you, sir. I would now request Professor M.N. Huda, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, BVI CAM, to address the participants with his inspiring words.
Good evening, friends. At the outset, let me welcome today's valued speaker, Mr. Vijay Anand. Last time when we had a kind of related topic, and this time again, we have Mr. Vijay, who is now with Capgemini. My dear friends, when in March 2020, the COVID-19 hit India, for almost a month or two, we were blank what to do. People were at home going into depression. Under the banner of IEEE Delhi section, we realized that there is a need to connect people for the purpose of learning and ensure that people are engaged into constructive, productive activities, and learning must continue despite the fact that disruptions were happening all around and the people were getting all negative news. Dear friends, then we started in June 2020 this webinar series, and this is our 51st webinar under that series under a weekly evening program, sometime on every week basis, sometime in alternate week basis. I take this opportunity to welcome all the participants who from different parts of the country and abroad has joined this 51st webinar of IEEE and Bharati Vidyapeeth series, and 6 more webinars, 3 in this month, in the coming month, that is December, and 3 in January have already been notified on the portal. If you have not registered by now, please register for that. My dear friends, COVID-19, to which we have been facing since last March 2020, we were thinking that now it is over. But since last 2-3 days, the kind of the news which is coming is again alarming. We have to be very proactive and apply all COVID-19 behavioral protocols to be safe enough. And this we are meeting through a distance because of that COVID, and the technology is to our help for connecting us together. And that's how I keep saying that almost 5 to 6 decades old share of Bashir Badr is very apt at this moment, in which he said that कोई हाथ भी न मिलाएगा जो गले मिलोगे तपाक से. We have forgotten our sanskar of doing namaste. Rather, we entered into meeting each other. And at that moment, Bashir Badr said that कोई हाथ भी न मिलाएगा जो गले मिलोगे तपाक से. ये कोरोना का जमाना है. उन्होंने उस वक्त कहा था ये नए मिजाज का शहर है. मैं कह रहा हूं ये कोरोना का जमाना है, जरा फासले से मिला करो. So with that distance we are meeting, my dear friends. Today's topic, which has been chosen on Industrial Revolution 4.0, is so apt that all of us know that at this moment we are in a pure digital age. Had we not been into that pure digital age, probably the COVID-19, which has happened all across the world, would have created disaster in terms of connecting people, in terms of continuing business, in terms of what we claim as business resilience. And when we are talking, Professor Subrata has introduced you from Industry 4.0 to Industry 3.0. As a student of computer science, we understand that Industry 3.0 was IT-enabled world, whereas Industry 4.0 is a world in which IT is driving everything in and around us. That is why it is said that IT-driven world having AI-enabled objects, devices, connecting in and around us like IoT, IoT, industrial Internet of Things, like Internet of Everything, etc., etc. My dear friends, still Industry 3.0, as a student of computer science, we used to say that technology models used to revolve around the business model. But business model more or less remained constant. However, by now, you might have witnessed that in last 1 decade, particularly 2 decades, but last 1 decade is very specific in that nature, that emerging software applications have disrupted the decade-old traditional business models. And friends, it will continue to disrupt it further. Most of the traditional business models, which were almost 5 decades, 6 decades, 7 decades old, does not exist now. So this disruption will continue, and disruption will continue manifold. And at a much faster pace, it is going to happen. Smart cities, smart factories, smart manufacturing, smart universities, which we also claim now Education 4.0, which under National Education Policy NEP 2020, it has been overemphasized now. Digital twins, machine-to-machine and device-to-device connections are going to be omnipresent in and around us. WhatsApp, Paytm, Ola, Uber, mobile banking, mobile ticketing, mobile-enabled payments of bills and utilities and other related services are an example which clearly tell us that in which particular way the decades-old traditional business models have been devastated and absolutely new business models are emerging. Friends, in the changing ecosystem of Industry 4.0, finally the bottom line will remain that business models are changing every coming day. Better and better, more flexible business models are evolving, which will continue to evolve, having technology as the driver under this new ecosystem of Industrial Revolution 4.0. Automation has found a new meaning, and it is going to reach more and more sectors in coming days in much more deeper way. The world is thinking about implementing ways and means to minimize the disruption caused to the humanity. And so this is an opportune time. This is a most apt time to focus on IoT, learn about IoT by realizing its necessities, its impact, because it is going to be accelerated in the coming days. Industry Revolution 4.0 is impacting the existing manufacturing and industrial process multidimensionally. This Industrial Revolution 4.0 has got additional momentum and a bigger role to play to facilitate, to rebuild the economy in the backdrop of COVID-19 pandemic. That is the reason why we have kept this webinar on Industrial Revolution 4.0. I'm sure the kind of the speaker I have invited from the industry, we will be enlightened about what and in which way the things in and around us are going to change under the new ecosystem of Industrial Revolution 4.0. What I wanted to conclude at this note, that around 2 decades ago, Bill Gates said, never before in the history, innovation has offered promises of so much to so many in such a short span of time. That is going to be a reality. That is going to be the rule of thumb. And that is what the benefits and the advantages we are going to take. I wish you all the best. Stay safe, stay healthy, stay vibrant, continue learning despite disruptions. Because the kind of the news which is coming from South Africa about the new variant is very alarming. All of us have to take care. Coming 2-3 weeks will tell us that how and in which way the world will be moving. And that's how very favorite 2 पंक्तियां मैंने पिछले जनवरी में लिखी थी कोविड के लिए कि वक्त नाजुक है, संभल संभल कर रहिए। वक्त नाजुक है, संभल संभल कर रहिए। जब तक ना हो बहुत जरूरी, घर से बाहर ना निकलिए। Continue learning despite disruptions. Keep attending these webinars. That is the purpose for which the IEEE Delhi section and Bharati Vidyapeeth, along with the collaboration of almost all professional societies having presence in the country, we are organizing this webinar. I take this opportunity to thank all my friends from different professional societies who kept on believing us and kept on collaborating us, because the time has come when either we have to get network or be ready to perish. That is what I wanted to say. And the purpose of this is continue learning, bring power of knowledge with us, so that whatever challenges are coming before us, we should be in a position to face those challenges. And that's how a great poet has said that उजाले अपनी आंखों में महफूज कर लो, उजाले अपनी आंखों में महफूज कर लो, बड़ी दूर तक रात ही रात होगी, मुसाफिर हो तुम भी, मुसाफिर हैं हम भी, किसी मोड़ पे फिर मुलाकात होगी. Thank you so much. Wish you all the best. Stay safe, stay healthy. Over to you, Dr. Ritika.
Thank you, sir. I would now welcome amongst us our expert speaker, Mr. Vijay Anand, Chief IoT Architect, Cape Gemini, Chennai. Vijay is a Senior Director and Chief IoT Architect in Cape Gemini, based out of Chennai, and plays a strategic leadership role building connected IoT solutions that mastermind technology direction and innovation for various market segments covering consumer and industrial IoT. Mr. Anand has over 27 plus years of experience and has also published more than 20 research papers at various wireless international conferences and has been actively engaged with the research and development institutions. He has also been author for the Best Paper and Outstanding Paper award-winning articles at various IEEE and international conferences. An active keynote speaker and having chaired several technical sessions in various international conferences, Mr. Anand is also pursuing his PhD at the Crescent Institute of Science and Technology. I welcome you today to this session, sir, and I would now request you to kindly enlighten the House. Over to you, Vijay, sir.
Thanks, Ritika, for providing the introduction, and thanks, Subhatra, and thanks, Mr. Hoda, for providing a good overview about the Industry 4.0. In fact, whatever I had thought about providing an initial introduction, I think you guys covered very well. Specifically, Dr. Subhatra has talked about the revolution that's happened from Industry 1.0 to where we are standing currently on Industry 4.0. I think that pretty much gives the way, right? The whole the digital transformation has happened so far. With that note, whatever introduction that has been provided, I'll just move on to my presentation. So I have just now covered my talk in the 3 different modules. Basically, each and every module will give an element about how this whole Industry 4.0 is moving on in different ways. The first module I'll try to provide details about where is the origin of this 4.0 and how this whole digital transformation is currently happening. What are the key elements, right, that have been considered in terms of the building the whole pipeline or the ecosystem for visualizing this the complete the 4.0 which people are thinking about leveraging various technologies. And in module B, I'll try to bring out a couple of market segments how this whole transformation is happening with the implementation that has been covered in 3.0, how people are trying to visualize to make it as 4.0 with the latest technologies, even like 5G as well. And then in module 3, I'll try to bring out certain technology pillars largely considered in building the solutions, and how this emerging elements is also been brought with other areas like a digital twin, 5G, and then the edge computing. So these are the buzzwords that you will hear from this particular presentation, and I'm sure that this will give you a clear overview in terms of how this whole market is moving on. What are the technologies that has been considered, and how this the solution has to be designed starting from a sensor node up to the cloud platform, and various students who would like to do projects or want to do research in Industry 4.0. I'm sure that some more additional details can be leveraged from this presentation. So I will just get into my talk. Before I specifically jump into Industry 4.0, I just want to give you a kind of data. What are the challenges as of now that we face in the manufacturing industry? So typically, if you see from the manufacturing automation systems, there are various challenges. Even today, also we come across from a safety standpoint. If you see the pictures, right, that has been showcased here. So if you see a factory kind of ecosystem, the most important element are the CNC machines. If even one machine goes for a toss, if it gets into a breakdown stage, obviously, right, there is a huge loss in terms of production, and it's very, very difficult, right, for people to see that how to bring this whole the mission breakdown into the normal state, and then convert into an the production whatever been expected. So that's major problem typically that we see in the smart factory ecosystem. Mission failures, breakdowns are the major cause, right, which basically shut down the plant as well at any critical stage, right. The problems are faced. And the other challenge, what you also see in the oil and gas industry, is the gas leakage. So typically in the pipeline construction side, if you see that any small leakage that you typically come across, right, a huge amount of loss that happens, and it also spoils the the external environment as well. This we have also seen in Chennai, from ONGC kind of the pipeline that has been constructed at different locations in Chennai city. And the other problem statement that you also see is the the power transformer, where sometimes the transformer gets overheated, and then it gets bursted out, and it also causes a lot of damage, both from a power generation perspective or power management perspective, as well as the environment as well. So various problems, right, that we come across, that we have also seen in the manufacturing industry. And the most important element is to see that how do you have some sort of safety regulations? How do we able to overcome various accidents, right? That's typically happens in a different factory environment. And that's one of the aspect, right, where this whole revolution has started moving on in a way to see that what is the kind of ability that we need to have it in in the context of Industry 4.0. While the 3.0 was initiated or was kicked off, I can say in somewhere in 1990, where my career was also started in that time. But that's where, right, all these PLCs and then hard protocol, different products started coming out with some sort of technology to see that how you would be able to measure and monitor the performance of a different equipment from a central monitoring system like a SCADA and all. That's where the revolution started happening more on Industry 3.0. And with the 4.0, as Dr. Subhatra talked about different technologies like AI, ML, cloud computing, edge, right, that we try to see that's evolving. So how those technologies can also be brought in as a part of Industry 4.0. So the Industry 4.0 is all about, right, how do we have the ability in order to track various operations that is happening on a day-to-day basis? How do we able to avoid accidents, and then how do we able to reduce a certain loss, and then manage the cost as well? And at the same time, how do we also improve the the employees productivity by having different monitoring mechanisms, and then able to bring out the different business model as well. That's what Dr. Hoda talks about it. The different business model that is typically emerging in Industry 4.0, and that's where, right, the whole digital transformation it's also happening to a greater extent to see that how do we reduce the loss, and then able to make more profit, and then bring out the larger productivity. So that's the the kind of view which I thought I will just provide from this slide in terms of the challenges that we see across the different market segments. So one in terms of smart grid or smart energy, the other challenge more in terms of oil and gas industry. The third is more in terms of the smart factory ecosystem. So whether it is a mission failure, or it is a pipeline leakage, or it is a the fire accidents that happens largely in the power distribution plant systems or in the bigger oil and gas industry plants. So typically the accidents and then the damages are so high. So how do we have a better technology mechanism in order to overcome some of these challenges as well? So today, if you see from the evaluation part, there are a lot of factories that anyway we have seen in the current scenario. So there are sugar factories, chemical factories, tools manufacturing plants. There are multiple plants, right? That's already exists. But however, if you see from the technology standpoint, it's been evolved quite large. And today we see that there are a lot of gaps that exist in the existing ecosystem. That's where many manufacturing plants are trying to see that how we could think about enabling some of those the technologies which are evolving. Either we talk about the edge computing, or we talk about digital twin, or we talk about AI, ML. Some of those technologies, how we could how those technologies can be brought into the existing ecosystem, so that you would be able to see a better the production quality, or the the kind of the revenue that could be considered, and how you'd be able to reduce the the maintenance activities as well. So today, if you see from the industry standpoint, not many factories are equipped with various technologies that we are talking about. Many factories are running with the same environment what has been designed, let's say 10 years back or 15 years back, but slowly people are trying to see that how they could move away from the existing system, and then bring out some of these current trends, so that the kind of value, right, that you're able to see at the end of the day. So for information, we have been talking to various customers, and most of the customers comes back to us and say that currently everything is working fine, but we talk about different technologies. This is can you guys help and then tell us, okay, by enabling edge technology, how much of performance, right, that I would able to improve in my factory operations, how much of business value I would able to see at the end of the day, how some of these, security, safety specific challenges can be addressed. So these are the kind of discussions that we have been having, and which is also very exciting in a way to see that how we could go and then understand the factory environment and see that how the operations are happening, where exactly we have to put our finger in bringing out certain new technologies so that it would be able to bring out a value back at the end of the day for the customers. So that's the way, right, the discussions are also happening with the various customers that we work on this, work on the industry side. So given the high-level view that I provided in the last two slides, so the Industry 4.0 is all about, right, how do you realize a vision of a smart factory? So the factory is all about, right, how do you connect the missions, the peoples, and then the physical assets, because these are the three things, right? Any factory, we know, you'll have a lot of missions, right, that will typically have in terms of manufacturing a different products, and there will be operators who will be operating the machines, and then there will be various physical assets, right, that you need to leverage it. So there are many key elements that comes as a part of the smart factory ecosystem. So how do you bring out a connectivity across some of these elements, which basically makes you to realize the digital transformation. So in terms of collecting the data, processing the data, and then analyze the data and see that what better way, right, the whole factory operations can be improved. And that's where, right, this Industry 4.0, the vision is all about in terms of how do you realize the element in terms of smart factory by connecting these three key elements. And in terms of realizing that, obviously, right, the things that have been considered in two ways. One is the horizontal integration, the other one is a vertical integration. So today, if you see any individual smart factory, as I mentioned, right, you will have a lot of machines, and then different equipments which will also have, right. It's not only the machines that you will use it for manufacturing any product. No, there will be other elements like motors, power transformers, diesel generators, HVAC machines. Many such elements will also be there as a part of the manufacturing plant. So how do you interconnect so many other aspects as well? Even in fact, the water quality treatment plants might also be there. So ideally, in order to bring out having connectivity with all these things, so people look at it from a vertical integration perspective to see that how do you connect all the missions, either in terms of star networking or mesh networking, or how do you connect with the wired, wireless. It depends. Different technologies can be considered for a different factory ecosystem. And further, right, how do you process the data very, very closer to the devices itself? That will help in terms of reducing the latency, and then taking some quick decisions as well. And some data, how do you pass it to the cloud so that a kind of machine learning element can be worked out by having a larger amount of data storage. Mean to say the historical data and then the current data. How do you predict the way, right, the systems needs to work and all. So this is how, right, this is the way, right, the whole now the vertical integration is currently happening. And I'll give more details on this aspects in the coming slides. And the other element what you also see is the horizontal integration. So you'll have two different factories at two different environment. Let's assume that a welding machine is one of the product, right, that needs to be manufactured, and then the factories could reside in different countries or different regions. So how do you basically interconnect two different factories, and then possibly the output of one factory should be the input for the other factory as well, for triggering certain process as well. So that's the the horizontal integration, which we have also seen in some of the the customer opportunities. That's also happening. So these are some of the things, right, that needs to be thought about it or needs to be considered, for creating the a smart factory kind of ecosystem covering both the vertical integration and then the horizontal integration. Horizontal integration, typically it may not happen for each and every aspects, but largely, by and large, what we are seeing to a greater extent is a vertical integration part. And given this, the aspects, at the end of the day, what is more important is to see that how do you able to reduce the cost and then improve the efficiency, and then also how do you predict elements in a way to see that what would happen in the next few days, and then what actions I need to take if something goes wrong. So the predictive maintenance is something, right, which people are trying to figure out what level of intelligence that we also needs to be brought into this, a bigger factory ecosystem. And the other one is a digital twin, which is quite emerging in a way to see that how the physical system and the digital system can be visualized in a way so that you would able to get a better blueprint of how this whole factory things are happening, and then able to figure out the places things can go wrong, and then able to make a quick decision as well. So that's the the kind of the overall the transformation that's happening in the current scenario. So I'll also give some details about a digital twin in module 3. So that's the the broader view which I thought I will bring out in this slide for people to know in a way to see that how this whole the transformation is happening in Industry 4.0, which machines, people, and the various physical assets in order to make an overall the digital ecosystem. The most important thing what today the customers are also expecting or wanting to do is to bring out the predictive analytics. Today, if you see, right, the standard operation is all about doing the corrective maintenance. So once a machine goes for a break, then you try to understand and then repair the machine, and then obviously, right, it takes a lot of time, and the cost will also be quite in the fact that, right, if the machine is down for one day, right, a lot of loss and that goes in terms of not making the production for that whole day as well. So that's one part. The other part is a planned maintenance, where regularly, right, every 6 months you just try to go and figure out, right, for each and every machines know how it is performing. There will be a standard checklist which will be more in terms of a scheduled way, right? The planned maintenance happens. But what is expected currently in the Industry 4.0 ecosystem is a predictive maintenance. Okay, how do you predict which can go wrong at some point of time for a different machinery parts, because there will be a lot of mechanical elements that also comes for a machine to operate. So there should be more and more intelligence needs to be enabled in the specific machine. Even if you take a motor, the motor itself, it's an important element in the smart factory to run certain machines, and if the what are the key parameters that needs to be measured from that motor, or even or if not the power transformer that would be used in the factory ecosystem. So which is very, very critical, and any one of the element does not function properly, right, it leads into a major loss. So predictive maintenance is what, right, it's been considered largely, and that's where most of the customers even comes to us to see that we have a lot of data available which has been recorded in the last 5 years, 10 years. With that data, how you guys could help us in bringing out a solution that could be able to help us in doing the prediction for different emissions, so that we would be able to eliminate the root cause, and then able to run the operations much smoothly. So more towards, right, how do you what's going to happen, how the problems can be prevented in advance. So those are the the scenarios, use cases, right, being brought to us to a greater extent, and how the predictive analytics or the analysis that could be enabled in the current the ecosystem which is already exists, and what kind of technologies the hardware platforms that needs to be brought in into that the system, so that the a better advantage can be realized by the product manufacturers. So that's the no, the most critical part I can say, what's been considered in Industry 4.0. So one element is one key aspect of what's been considered is the safety. Safety is very, very important. So where we need to keep monitoring the whole environment to see that what are the various safety aspects that needs to be considered. So surveillance plays a major role by having a video analytics. So that is one part. The other part is all more about the predictive analytics. So how do we ensure right the failure scenarios are very, very less, so that there is an increased production and then there is a decreased downtime. So that's the key things that typically been considered in the Industry 4.0, for which there are a lot of technologies. So which technology that we need to choose, and then which algorithm that we need to bring out, it again depends upon the case to case basis, and then how do we address it. So given the overview about the ecosystem of Industry 4.0, about the horizontal integration, vertical integration, the key technologies, and then the importance of predictive maintenance, I will just try to talk about two market segments. There are multiple market segments that we see from the business standpoint, right? Lot of opportunities that we could see. The first and foremost is specifically in the oil and gas industry, and lot of things where people wants to bring out various the technologies enabled into it, because the existing systems are all based on SCADA, which I will talk about. It's more towards monitoring and controlling, but it's nothing more beyond the the monitoring and control part. That's where this the edge concept or the AML elements comes into picture, to see that how do we further enhance the system beyond SCADA, and then bring out the the platform which should be able to provide a better a view about the overall operations of the factory ecosystem. And the other areas what we also seen is on the smart grid, and then the smart power, the healthcare, and then the utilities. So these are some of the market segments by and large. Of course, the transportation and logistics are also there. So I just highlighted 4-5 market segments. There are multiple market segments that's been mapped under 4.0. But to a greater extent, these are some of the the segments that we see. Larger evolution is happening in terms of enhancing the existing system beyond the SCADA or the product set which are already being used. So the first one which I was referring is the oil and gas industry. So if you look at this slide, it gives a view about various elements, right, by and large being considered on Industry 4.0. So the foremost part, what you see is the the preventive maintenance, which I was talking about it. Typically, if you see the background image, which has been put in light mode, but you'll see a lot of tanks are not typically being constructed for storing a different chemical products. And obviously there will be a lot of other elements, right, that comes as a part of this ecosystem, which will be your pumps, your valves. So many pumps you will see, and a lot of valves which manually, right, many operators try to open and close for a different operations. So typically, if you look at in a larger oil and gas industry plant, you'll see thousands of valves, and then hundreds of pumps, and all these pumps and valves needs to be monitored and then maintained regularly, so that there is no leakage or on the non-functional aspects, right? So that's the critical part. So that's when the preventive maintenance comes into picture, in a way to see that how do you collect the data with respect to various operations of these pumps and valves, and then of course, apart from this, there will be so many other products that you see in terms of the temperature transmitters, pressure transmitters, the pH sensors, and then the flow meters, the mass flow meters, and then the level sensors for the tanks. So not many the products or the stuff will be used for running this entire plant. So just imagine, right? So much of data that you would able to gather from these instruments. So how do you measure, monitor, and see that, right? From the maintenance standpoint, how do you manage it? The other element is a pipeline leakage detection. So in the very first slide, I was just showing a picture. Even a small leakage, from any of the pipeline, right? It leads into the major disaster. It could be a gas, or it could be a petrol, or it could be any other chemical products. So no, leakage is very, very it's a very important element to see that how do you identify the leakage, even it happens very quickly, and then which location, right, the leakage is happening is another element. So that's the way, right? The technologies are being considered in different ways. Typically, if the pipeline layout is more than 20 kilometers or 30 kilometers, so identifying the leakage is very, very difficult. So there are certain technologies being considered or being applied even today, right, to identify the leakage direction. But how do you even bring out a much more value add by having an industrial IoT kind of elements, so that it helps to make the operations much faster. And the third one is the workforce tracking. So different work, a lot of workers will be there in the manufacturing plant, and you need to track these guys, which are the areas they are supposed to work, which areas they are not supposed to enter. So some of those elements, right, the workforce tracking is being it's the other aspect, right, being concerned oil and gas industry. And with the COVID-19, and the most important element is all about, right, maintaining the social distance between the workers. So that's the other angle also being considered in today's scenario. And then the tank level monitoring is the most critical part, because you will see plenty of storage tanks in a different oil and gas industry. So how do we look out the monitoring system and asset tracking, and then the video analytics is what mostly considered today, because in any larger plant you'll see hundreds of cameras that would be mounted, but not all the surveillance, right, that you monitor, that you view it on the screen, it's been addressed so closely by any human being, because it always leads into error. The statistics states that 19% of the video goes unseen, and then 95% of the incidents, right, mostly gets missed out. So how do we move away from surveillance, and how do we get into analytics, so that right, while you capture the video from the camera, how do you bring out some sort of analytics with a certain modeling, so that a lot the alerts are generated okay, to the plant management team, or to the maintenance team, so that they can go and solve the problem very quickly. So after damage, and then monitoring the video, trying to take an action is of no use today. So how do you even move away from the surveillance, and then do a better analytics? So these are the concepts, use cases, right, to a greater extent being considered from the oil and gas industry. And this is an area where we see larger business opportunities also happening across the globe from different customers. And smart grid is the other the market that we are also seeing more and more opportunities. Typically, the smart grid is a place where you'll see a lot of poles deployed in a different places, right, where the cable layout happens. And so the bush that's typically being used for connecting the wires, sometimes the bush gets corroded, and then there will be a lot of sparks that gets generated. So more ideas to see that how you can even use the drones in terms of monitoring those bushes and capture the video and see that what should be the level of the quality the bush should be there, and then how do you replace it if something if the damage is happening. So that's one part, right, typically that you see in the smart grid ecosystem. And apart from that, the power transformers and then the diesel generator functionalities, how do we monitor some of these equipments in a better way so that the service can be provided to the end consumers as expected. So smart grid is the other area. So where we typically see the opportunities that are mostly happening on the power distribution as well as on the the power consumption areas. So power consumption, we know it's more on smart buildings, smart homes, and smart factories. So that's one area, and then the power distribution is the other place where you distribute the energy after you receive it from the power generation plant. So the distribution and the consumption entities are the areas where we see now the market is quite exhaustive, and a lot of implementations happening with respect to the technologies that we are coming across in today's world. So that's the aspect about the module A and B, and I'll just quickly cover the key technology pillars that's been considered for 4.0. I think this is a section the students or the the research scholars may have to look at it so that they can pick up any one of this element and see that, right, how they could do certain research work in building any solutions or algorithms also. So the first one, what there are about 7 the technology pillars that's been identified in terms of basically basically for making a digital factory or a smart factory, and these are the principles typically being applied in creating this the factory ecosystem. So the first and foremost is the the IoT or the industrial IoT that we call it, because IoT being considered in the two broader elements. So one is a consumer IoT, the other one is industrial IoT. Consumer IoT mostly goes in the context of smart retail or smart homes. However, the industrial IoT goes in the context of factory, or in the context of automotive, or in the context of smart grid, smart power, smart factory, smart city. So that's the classifications, right, being considered from the industrial IoT standpoint. So IoT is one element, and how do you bring out certain technologies in the factory ecosystem so that you would able to improve the operations in a much better manner, and then able to even bring out the security also. The other element is the edge. So whether you want to send all the data to the cloud, and then the cloud needs to do the operations, or you want to offload on the cloud functionalities closer to the devices, which will be the edge, and then how this edge can do a better job in providing a quick response, reducing the latency, and able to provide the better quality of service as well. So that's the other trend being considered greatly. And under the cloud, obviously, we all understand, right, how you could bring out artificial intelligence, machine learning with a huge amount of data that generally gathered from various sensors. And that's the other angle that comes as a part of the cloud platform. The fourth one is a security. So while we talk about a bigger smart factory ecosystem, so there are plenty of data, right? Sensitive data, very very sensitive data that gets generated from different machines. And if someone, an external hacker, could be able to get inside the network and hack it, then the whole plant operations, right, goes for a toss. So cyber security is very very important, and how do you take care of addressing the data security, device security to a greater extent is very very important. And so this is a place where customers also very much concerned to see that how from a solution perspective the security can also be addressed. And the fifth one is the simulation part. Obviously when you try to design a system, you first have to simulate it and see that, right, how this factory ecosystem could work with the different machines. And that's why the digital twin concept has been considered today to see that how you could get the actual digital view out of it, from a physical view, and the kind of data that will flow from different machines, different equipments in different paths, like a blueprint, right? You would be able to see and then figure out where the things might go wrong or it's going wrong, and how do you able to improve the performance of the overall the factory system. And along with that, the augmented reality also plays a major role in doing this whole the simulation part out of it. And the sixth one is the robotics. So for the car manufacturing plant, right, the robots are being considered largely, and obviously this automated guided vehicles that is also being used in some of the smart factory system to deliver the product from one place to another place. So robots are being being visualized to a greater extent for the factory ecosystem. And last but not the least is the additive manufacturing, which is a 3D printing part. So typically, if you see from a technology pillar standpoint, these are the seven technologies that are considered largely for designing a smart factory. And I'll just get into the details at the very high level, so that you guys would be able to get some view out of it. And so, yeah, IoT, I'm sure that today most of the people might be aware of what exactly the IoT is all about. So IoT, again, is not a technology. It's not something, right, we see as a different view. It's like a conceptual framework, okay, which basically comes from the idea of providing the connectivity, and then creating an intelligence from the connectivity in order to improve your efficiency, and then reducing the cost. So that's the way, right, this the whole IoT thing is all about. So IoT will have things being so the first part, what you always call is a thing. So when you try to have a microcontroller embedded into it, then it becomes a wireless sensor node, and the node will have different connection endpoints, where it could be a Zigbee or Bluetooth or Thread. You can define, right, what kind of a connectivity we need to, or an NB-IoT kind of interface can also be considered, which generates the data, and the data further you store the data, and then do some and a computation around it, and then further you do the analytics out of it. So the whole ecosystem, what you see here is what been called as IoT. But at the end of the day, while we try to do it, many end customers always want to say, what is the business value that I would get if I try to bring these technologies into the ecosystem. So that's where the discussions, the strategy, all comes in a way to see that how do we connect all these dots. And at the end of the day, if I invest this much of money in bringing these technologies, ideally at the end of the day, what value I would able to say, whether this will reduce, let's say $10K, mean to say, like, if I able to reduce the cost of 10K, and then improve by 100K of value, is what, right, and the discussion always comes out at the end of the day. And so this is the way, right, the whole IoT is all about. And as I mentioned, each and every equipment that you use in the factory ecosystem, it's all the data that you collect from various machines, and the huge amount of data, right, that gets transferred to the cloud platform. And then you need to have a larger storage, and then data processing, and then do the processing, and then get the response back, and then see that what action to be taken. But the only limitations that you see in this whole ecosystem is the area where the whole concept is it's being designed from a centralized environment perspective. So you collect the data from the from the machine, and then you pass it to the cloud blindly, and then the cloud is the one which will have all the intelligence. But sometimes while we try to do that way of transmitting data, it basically leads into waste of bandwidth, because so much of huge data that needs to be sent out every minute or every hour. So you need to have a very strong network connectivity to send it to the public cloud platform, and it also leads into higher latency and higher cost. And some data which also generated by the equipment, let's say motor, for some reasons, right, for mean to say, like certain data now may not be needed at all. So unnecessarily, right, we those data will also be, it's also been sent to the cloud, and then you try to use the data which will not have any practical value also. And the major challenge that also comes is about the security, because once the data goes out from the factory environment and then passed on to the cloud, there are very high chances, right, the data can be hijacked or it can be attacked. So those are the limitations that also comes as a part of the the IoT ecosystem, and that's where the edge plays a major role in a way to see that how some of these challenges can be addressed. So the whole idea is to see that you bring out an edge gateway or an edge layer within the factory environment, so that so much of equipments that transmits the data to a greater extent, all this data, right, can be processed very quickly within the factory environment by this edge gateway, and then able to have the decision making quickly, and then we can have a lot of policies enforced into that ecosystem also. So, and then only and from a machine learning perspective, in terms of knowledge base and other stuff, right? The cloud platform is also being considered, but by and large today, the factory environment or the factory ecosystem, it's more towards having a different edge nodes. When I say node, we can easily map it to like a temperature transmitter or a pressure transmitter or a mass flow meter or a pH sensor or a motor or a diesel generator or an valve. All those things is what, right, would be considered as an edge nodes in the industrial 4.0. The ecosystem, and how do you handle the data processing closer to the devices itself. So that's the the trend which is happening from the edge standpoint. And so from the ecosystem perspective, like you'll have the sensing nodes. Even today, the nodes also being considered as an edge nodes, and that's what you would see here in this diagram. Where it's not just temperature transmitter just blindly send the data even to the edge gateway. The temperature sensor will have the intelligence to see that, okay, whether this data is a valid data, whether I need to send this data over Zigbee or Wi-Fi or any other network, right? So the nodes itself are having intelligence into it, and the nodes will take a decision to figure out whether this particular one bit of data to be transmitted to the gateway or not. So that's where this whole the pipeline gets built, and so you have the edge nodes, and then you have the edge gateway, and then most of the operations happens within the ecosystem itself, and then you try to send some data that might be needed from a long-term storage perspective or from an historical storage perspective, which can be done on any commercial cloud platform like AWS or Azure or GCP. So this is how the kind of ecosystem design or the principles, right, typically being applied in the Industry 4.0 ecosystem by connecting all the dots and then bringing out the relevant technologies to realize it. So this is where the IoT, the edge computing, or you call it as industrial IoT. That's way, right? This things are getting developed, and a lot of products, right, that is also coming out. With a certain protocols enabled, so that you try to make most of these systems with the wireless, avoiding many wired element that exist today in different factory environments. So this is some of the sample gateways that typically been considered for creating an edge product. So Google Coral or NVIDIA Jetson AI or your Raspberry Pi can be created as a clusters, and AWS have their own box called Snowcone, which also been considered as an edge gateway. Dell. So multiple gateway products which are there in the market. This is just 2%. I'm just showing that there are much more products which are there in the market as well. But from a research and development perspective, typically Coral, NVIDIA Jetson AI, Pi as a cluster is largely used for building the proof of concepts, or doing the research work as well, which has a very good embedded need to say the computing capability from the video analytics perspective also. So that's the element of IoT or industrial IoT along with the engine intelligence. The third one, which is about the SCADA part. So this is what I was mentioning. So today, most of the manufacturing plants that you see, it's all built with various PLCs, and then the data that you collect from PLCs or the interface with the machines on the left hand side, and then interface with the SCADA system on the right hand side, which collects all the data, and then the users would be able to monitor the overall performance. So SCADA is typically used for monitoring and controlling the plant, but the SCADA system does not have the other element that we are talking about in the context of your edge computing, or in terms of AML, and with so many other aspects into it. So the SCADA system is a very mature system, and it's an existing system in various factory environments. But it's more on looking at from a perspective of monitoring and controlling the plant, where where the plants has different equipments around it. However, from an industrial IoT perspective, or from an industry 4.0 perspective, it's beyond the SCADA, where you try to take the data out from the factory and then pass it on to the cloud, and then you try to bring out so many other aspects into it in terms of the device management, in terms of data visualization. Much more things can also be enabled by extending the connectivity beyond SCADA. So that's where the 4.0 plays a major role in expanding the ecosystem slightly higher with the different technologies. So from a data perspective, it's all about getting into moving away from big data to faster data. So the action is all about how do you process the data very, very quickly, and then able to analyze the data, and then take some actions immediately, because these data is not like the data from a smart home environment, where some decisions can also be taken in a different manner, whereas in Industry 4.0, the decision have to be taken much faster. So so much of data that we try to gather from a different equipment. So how quickly, right, you would be able to process the data, and the faster data in motion is very important. So the way, right, the market is moving is to see that how do you move from the big data to fast data, where the data is in motion, and then able to monitor, act, and then decide very quickly in terms of taking an action. So that's the angle being considered from a data perspective. And the selection of database is very, very crucial, because from a factory environment, as I mentioned, right, you will see larger volume of data gets generated. And there should be a characteristics that we need to understand what is estimated volume of data that gets transmitted per minute or per hour, and how frequently we need to write the data to the database, how frequently we need to read the data from the database, whether the data that we are receiving is structured or unstructured, or how the data have to be queried, the data process decision mechanism. So how do you split the architecture, by having some data storage on the edge and then some data storage on the cloud. So many elements now comes into picture. So from a design perspective, right, database selection is very important. At the same time, right, how do you also split up the design between cloud and the on the edge in terms of hot database, cold database, and what kind of database needs to be chosen. All some of the important decision making that needs to be done when we try to when we try to bring out a solution around it. It's always easy to give a view about a perception of a database is needed, but what sort of database is needed, selection of database is also quite important. And just to give you a view about from an Amazon standpoint, if you have to design the solution using AWS services for a digital factory, so how the end-to-end pipeline would look like, and so that this is a diagram I thought I'll just bring out so that if people can also visualize right how this solution design generally happens. So you have various factory machines, and there is a protocol conversion that needs to be done for AWS to understand the message. And Greengrass is one service that is typically used for the edge computing, and then the data is being sent to the AWS IoT core, where right all the other elements of data processing, data management, analytics, and SageMaker is a service right that typically being considered for machine learning, so that you model it and then send the provide the response back as an inference, so that the data has been the model has been pumped back to the Greengrass service, and the rest of the operations happen. So very simple approach in terms of creating an industry 4.0 ecosystem with the services right that Amazon today provides, and this is one way of designing the solution as well. So the other technology pillar, what I was referring is the security. So as I mentioned, security plays a very, very major role. This itself is a core research work where many people are working on it. And today, a lot of SoC vendors, whether you take Qualcomm or Broadcom or NXP, or ST Micro or TI Citara or MediaTek, most of the SoC vendors are bringing out a trusted platform module as a part of the chip. So that any data that you gather from the machines through an electronic system, so all the data right goes through the trusted platform module, where no specific algorithms are enabled for encryption and decryption or for authentication, right? So the trusted platform module or the trusted execution environment plays a very, very major role today in the IoT ecosystem in order to address the security challenges. If you guys are keen to work on the security, and then just understand more on this TPM and trusted execution environment, that will give more idea about how the security challenges are typically being identified to address the various challenges using those modules as well. So data communication between the devices and the gateway, under the gateway to the cloud. So you have two levels of security challenges. So there is a security needs to be addressed between the device and the gateway, and then the security needs to be addressed between the gateway and the field gateway and the cloud gateway. So the attack can happen largely in this area, and that's where right the security things needs to be focused more and more, and so that's one of the critical element which been considered largely in the manufacturing plans, how the security can be addressed largely in terms of device security as well as the data security. And again, the factors that needs to be considered, from the security standpoint. So where that the devices are getting connected, how to whom the device is actually communicating to, how many ports are open, and then how much of data right the device sends and receives. And then the audits, right? Certificates are typically used for authentication between device and the gateway. So whether the certificates are active or it needs to be revoked, or it is pending for revocation. So all this data right is very, very important from a security standpoint. And then the firmware updates, and then the troubleshooting mechanism. There are much more. I'm not able to cover everything. This itself is a topic right that we could talk for 1 hour or 2 hours also. So security is very, very important, and that's the biggest challenge that also comes from the solution design perspective. So the attacks can happen directly at the sensor nodes. The attacks can happen at the gateway, or the attack can also happen at the infrastructure as well. So there are different levels of attacks being identified, and there are many elements that needs to be considered to design the solution by taking care of the security. So AWS brings very good services like a device defender, device management. If you guys are interested, go through some of those services. That will also help you to understand how this, the security parts have been, are being addressed largely with those services also. The fifth one is the digital twin. So as I mentioned today, now you have a physical space, you have a digital space. So the physical is the one that you already have it as a part of the factory. So how do you look at a digital space so that you would be able to see the behavior of the plant? It's more or less like a simulation, right? You simulate the whole environment with this kind of blueprint, like a digital space, so that you will know that how this whole data is moving on, how the equipments are working. So all these things can be monitored very greatly, and then you can have a prediction mechanism to see that which are the places, right, the failures are likely to happen, and then how you would be able to take some quick action around it. So digital twin is something which we're also seeing as an emerging trend today. Some of the customers have asked us to to help them out in creating a digital twin platform for them to monitor the whole ecosystem with the different functionalities, features, right, that they would like to monitor and then analyze it. So this is something it's another trend. And so this is a simple screenshot, like an oil rig as an example, how a digital part being considered, how the physical part will generally look like, and how you would be able to visualize from a digital ecosystem perspective, and what are the softwares typically being considered for realizing this digital twin. This is also an emerging area. If the students are more interested, you guys can also read this space as well. And the other one is the robots. Typically, for many, for various manufacturing plants, even the car manufacturing plants has a lot of robots that being used for improving the efficiency. And today, the cobots are being used largely, and that's where we could see the trend is happening in the industrial 4.0 automation system as well. So robots also plays a major role, and AGV is another trend that we see in a different private 5G private networks. People are more focusing on creating these very small robots, right, which are going to carry the product from one entity to another entity. So robots also plays a major role. And then the last one is the additive manufacturing, which is the 3D printing mechanism, where you need to, when you want to manufacture a product, right, it's more towards making a scenario in the context of the three-dimensional element, where people consider the additive manufacturing aspect in terms of designing the product and see that how much less material can be used, and then for a different the complex shapes, right, that have to be designed or created. So that's the other angle that we have seen on the additive manufacturing. We don't do much work on this area, but as a trend, this also driving the industry 4.0. So in a nutshell, this is what the industry 4.0 is all about. On the floor, that you see that different equipments that comes out as a part of the smart factory. It's a pictorial view, and with this pictorial view, how do you also bring out an IoT angle into it, so that you have various data collected and you process the data on the edge, something on the edge, and then bring some data onto the cloud, from a long-term perspective in terms of doing the historical analysis. So typically, a pictorial view, what you see from an Industry 4.0 is all about having different equipments working on different technologies, short range, long range, and then creating an entire pipeline around it. Yeah, so with this slide, I'll just stop it, and then I will look for Q&A. So typically, the questions that we need to ask ourselves when we want to design a smart factory. So what are the aspects that I have to think about? And this is very important, right? Anyone can pick up any technology and then try to say that, okay, this is how the system design needs to be done. But how do you ask questions so that it becomes a more better way of creating an ecosystem as well, all the solution design. So do I need to partition my networks at different levels, or how do I select a proper database for handling larger data, and then how to optimize my day-to-day operation cost, and then which are the protocols products that needs to be chosen in terms of bringing out a better the solution design. How do we handle the security? How do I predict the failures in advance? So we talked about predictive maintenance. So these are the the key factors always needs to be considered when we have to get into a factory design, which could be 5 machines, or that could be 10. When I say machines, we can look at it as a device. It could be 5 devices or 10 devices, or it could be 100 devices. But whatever it may be, right? The most important element is to understand the factors that we have to think about it before we put our hand into the design to see that how do we create this overall ecosystem. Yeah, I think that's my finishing touch. So Industry 4.0, it's all about the key technology pillars that I was talking about. More and more important is to see that how do you improve your the production, and then reduce the the operations efficiency, taking care of the the safety part. Those are the key elements, and a typical industry ecosystem, as I mentioned, right, you see so much of products. I mean to say the equipments, right, that typically used in the smart factory, and then bringing everything into the a digital way of collecting the data, processing it, analyzing it, and then taking an action. Is a critical part. And today people talk about 5.0, but still at a very early stage is more towards having an advanced the human machine interfaces is the trend that being considered, but it's still too early. But there are articles which is also coming about from a 5.0. Yeah, I think I'm done with my talk, and I'm just open to any questions.
Thank you, Vijay. Thank you so much for the wonderfully informative session. I have really enjoyed knowing all the aspects of Industry 4.0. And the first question I'd like to put is right from my side, with your permission.
Sure.
With Industry 4.0 and all these technologies, there has been a vehement debate. So what is your idea on the concept that will Industry 4.0 reduce manpower requirements in the industry, or it will open new avenues for co-working of man as well as machine?
It will in both ways, Dr. Ritika. So the most important element is to see that how do you reduce the manpower and then improve the operations efficiency. That is the foremost part, I can say, right? It's been considered to a greater extent. However, at the same time, in my first slide, I was talking about it. Industry 4.0 is all about connecting peoples and machines and then various assets in order to even have a better connectivity out of the whole design part. So in my view, right, it basically addresses both the things. But the foremost part is to see that how do you basically reduce larger manpower, so that your operation efficiency becomes much higher, your cost is also reduced, and able to run the operations in a much more automated way.
Absolutely right. Next question we have, how does this automation policy go with a labor-intensive country like India?
Sorry, can you repeat the question again? Automation.
Yes. I would repeat the question. The question says, how does this automation policy with Industry 4.0 go with a labor-intensive country like India?
The automation policy, when we say, right, typically typically from a technology standpoint, so most of the the policy goes as a sort of a rules engine that that gets configured at different endpoints. That's the first part of your question, right? Which I would like to answer. That automation policy, when we say, it's more towards making all the equipments configured from an operation perspective to see that how the equipments can be handled from their own point of view. So that's what I was saying, right? Today, the nodes that typically being used in the factory, which could be a motors or pumps or the valves, you need to have a lot of human power, the humans to go and then attend different operations. But today the nodes itself are becoming more and more intelligent to see that how the automation policy can be applied into some of this ecosystem, so that the labor cost goes down to a greater extent. So that's the kind of the trend which is happening, and along with the predictive analytics, how you would be able to now have the automation system even much more improved from the current design, so that larger elements are being considered. In India, as we know, right, like most of the operation plants has a larger number of labors, and the whole intent is to see that how do you reduce the number of labors and then make the system much more automated and advanced with the different technologies being considered. I hope I answered question to some extent. But
absolutely. Another important question that we have, how can industrial operating cost be reduced, though currently the technology cost in a country like India is very high?
See, technology cost, I'm not sure whether we have to consider from a high cost perspective. Today, the platforms, whatever that being considered for, let me show you a diagram. Okay, so for example, even this gateways that I'm talking about, so you need to have a lot of edge gateways in the smart factory. So today, if you look at from a cost perspective of these gateways, where you can make it as a kind of a good finished product, the cost doesn't go much higher as well, I can say. So of course, it all depends upon the kind of technology protocols that we want to consider, because many technologies are there in the industry 4.0, like a Profinet, a Profibus, Modbus, and then OPC. So of course, when we try to bring too many technologies into a bigger factory ecosystem, with the kind of products which are already available in the market, and if you want to use it, possibly the cost could be high. But however, if we have to bring out a better ecosystem in a much low cost perspective, there are different reference platforms available which could be considered in order to reduce the cost of the development also. So there are ways and means that can be considered. Not necessary the cost will be much higher, because the way the market is moving on today, most of the factory systems are all based on wired. And the whole intent of this industry 4.0 is to see that how do we cut the wired ecosystem and make the ecosystem more and more wireless, so that your cost part comes down very drastically. Because when we get into any wired ecosystem, by connecting too many PLCs and then too many sensor nodes in a wired manner, that's where the cost goes very higher when you want to create an industry automation system. But however, in today's trend, with the short range technologies and then with the long range technologies like LoRa, and then NB-IoT, so many technologies, right? People are referring to it. So that way, when you bring, the solution design with these specific technologies, you will see that when compared to wired, cost will be very, very less.
Absolutely, rightly said. I would completely agree with that. Another question we have, what are the possible attacks on an IoT-based system?
Sorry, what are the possible?
Attacks on an IoT-based system.
The possible attacks, as I mentioned, right, the attacks will be more and more on different endpoints. So this is the most critical part I was referring. So attacks will be on the sensor node. The attacks will be at the gateway entry point. Attacks will be on the cloud side. So the first and foremost part is to see that when a solution is designed, which are the possible places that the attack can happen. So when you try to expose the data, to an external world where the data have to go through internet path and then have to get stored on the cloud platform, that's a place, right, where the major attack happens. So that this is one of the area, right? The attack surface happens largely, and that's what I was talking about, the trusted platform module or the trusted execution environment. The scenarios, which been considered largely to see that how this security challenges can be addressed to a greater extent.
Thank you so much, Vijay sir. I think the questions can continue for a long time. I would end this up with the last question, which many of our attendees have asked. What are the current hot research areas in this field?
So research areas, I can say, right, three categories. So connectivity is one of the core research area. So I would anyways suggest students or the research scholars to focus on connectivity. So connectivity again plays a major role. When we look at it from a short-range connectivity perspective also, there are a lot of challenges that comes into picture. For example, a field gateway needs to handle connectivity with three technologies. Let's say, you need to handle the connectivity with respect to data just generated from Zigbee, or it gets generated from your thread, or it could be from Bluetooth, or it could be from LoRa. So different, connectivity standpoints, right, that comes into picture between this, field devices and the field gateway. I think I'm sharing my slide. Is it not? Or I stopped it?
No.
So I was just referring to one of the slide which I was showcasing. So the connectivity is one research area I would anyway suggest students to look at it, and the second one is the security, which is the other the research, and third one is the interoperability. Interoperability is also one of the place where different messages, different protocols, say for example, Modbus, Profinet, Profibus, different technologies, hard protocol, and a field gateway needs to handle so much of data that comes from these devices. So interoperability is the other angle, and the fourth one is the analytics, which I would like to say data analytics. Today comes as a key part. Where do you want to handle the analytics? You want to do it on the cloud, you want to do it on the edge. In that case, right, what kind of technologies, whether I need to bring Kafka on the Raspberry Pi or Apache Spark or on a MERN stack or a MongoDB database, which are the elements, right, that I have to bring out on the field gateway for doing the analytics. So in a nutshell, the questions which generally many students always has is on the areas where I do the research. I anyways suggest that pick up these four areas. Look at connectivity, southbound interface, northbound interface. That's one key area. And then the second one is the security. The third one is the interoperability, and fourth one is the data analytics. And yeah.
Yes, sir. Please.
So what I will do, I'll just let me share my screen now. Can you provide?
Yes, sir. 1 minute. Manish sir, I think we can. There have been some presentation. We can again share the presentation rights. Just a minute, sir.
It's okay, Kritika. What I've done, I've just shared few links via chat box. So these are the recent publications which I've made from Capgemini. It's just 2 months old. So some papers gives idea about how the hedge trends are moving on, and then the.
So you can share it. You have the presentation rights.
Yeah, Vijay, otherwise your links are good. People should read that. And I mean, those are good links and good
Absolutely.
documents.
The chat window is already full with people already appreciating the session.
Excellent.
Yeah, Jay, thanks. So, Ritika, these are the 4 links. In fact, these are some of the blogs and then the the tech articles being published. I'm sure that this will be more and more relevant for.
Yes, dear participants and researchers, we can immediately take a screenshot of the same.
And I've also shared this in the chat box as well. People can pick up and then download it, and then they could even refer it. In fact, zero touch is one trend which is happening in the IoT world. So how do you provision the devices easily without doing manual configuration and then wasting time in providing the connectivity? So how do you bring out zero touch without having any technical support? So this is the the other market trend which is emerging with the eSIM iSIM concept. So I'm sure that this would also excite the research scholars to understand and see that if any projects can be done. Again, this comes under the connectivity part. So these 4 areas is what I would suggest for the students to focus on the research work. Anyway, I'm also now working on those areas with the various research students, and I suggest the same thing to others as well.
So absolutely, for the research candidates and students, they can extract information from these links. And yes, they may also connect with Vijay sir if they pick up any of these areas for further research.
Sure,
So,
yeah. Absolutely.
Yes.
Ritika, we'll be more happy to support.
Yes, sir. So that is for sure. And with this, we come to an end of this wonderfully informative session. I would now request Professor M.N. Hoda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, to commemorate Vijay, sir, with this small token of remembrance from our side. Sir.
Mr. Vijay.
Yes, sir.
It has been a fantastic webinar yet again by you under this IEEE BBI Camp series. And this certificate is not as a certification, rather it is a remembrance that you have been part of this wonderful webinar. And if we want to take up questions, probably another 1 hour will be required, but good, you have shared many links, and those who wanted, they may collaborate and go ahead. The purpose of these webinars are to ignite the minds, make them to aware what is the current state of art. You have gone beyond that. So thank you so much, Mr. Vijay. We'll meet again.
Thank you, sir. Thanks a lot for providing an opportunity. Thanks, Dr. Ritika. Thanks a lot. Thanks, Ajay.
Thank you so much to all dignitaries, Professor Subrata, Dr. Subramaniam Krishnamurthy. I could see amongst the attendees very, very senior people, Professor Ansari, and I could not name very, very senior people, Professor Shrimali. So thanks to all of them. I'm sure they might have generated the certificate. This webinar room, meeting room, is now converted into a call center to resolve the queries of the attendees who wanted to generate certificates. Unfortunately, we have locked the meeting room. So those who are attending it as a live streaming session on YouTube will not be in a position to generate certificate. That is only a knowledge acquiring sessions. So thank you so much, all the participants. 6 more webinars are notified. If you have not registered, do register at the portal so that you can get timely information. Wish you all the best. As I said, कोरोना दोबारा दस्तक दे रहा है. जब तक जरूरी ना हो, घर से बाहर न निकलिए. Let's fight together to not to allow us to penetrate in our country. Wish you all the best. Dr. Ritika will be controlling this center for the purpose of resolving your queries related to certificates. Thank you so much. Wish you all the best.
Thanks, sir.
Thank you, Mr. Vijay. Thank you once again. Wonderful webinar.
Thanks.
This topic is so exhaustive that even if you continue speaking for a week time, you can't do justice. But in a very short time of almost 1 hour, whatever you have done is much more than what we expected. Thank you so much.
Thank you, sir. Thanks a lot. Appreciate your time. Thanks, Dr. Ritika. Thanks a lot.
Thank you, Vijay sir. And thank you to all the distinguished panelists and participants. I once again thank all our distinguished panelists and participants who have continuously supported us through all these webinars. A big thank you to all of you who have joined us on this auspicious day. Our next webinar is planned on 4th of December and the details are already available on our website. So dear participants, I request you all to kindly register for our next webinar also. I can see the number of participants is continuously going down. So that implies that all our participants have received the feedback link and have successfully generated their certificates. For other participants who are still there with us, I request the participants kindly fill the feedback form, because dear participant, until and unless you fill the feedback form, we will not be able to generate your certificate. So please fill your feedback form and submit it on time so that your certificate can be generated and delivered in your inbox. Till the time you do not receive the certificate, kindly do not leave this meeting room. We are there in the meeting room to help you out. So after filling the feedback link, if after 10 minutes you don't receive the certificate in your inbox, if it is not in your inbox, kindly also check your spam folder and mark it as not spam to receive the certificate directly in your inbox from next time. So if you do not receive it anywhere in your inbox, we are there. You can share your email ID with all the panelists. The ones who have successfully received the certificate, thank you so much for being part of this session. And I hope you all will join us back on 4th of December. So thank you, dear participants. Thank you once again. The ones who have received their feedback forms are most welcome to leave this meeting room. Hope to see you back on 4th of December. Take care. Sanjay Behel sir has shared his mail ID. Manish sir, we can help him with his feedback form, with his certificate. Vijay Singh Rathod, the feedback link is in the chat window. Manish sir, SK Muthu sir has also shared his mail ID. Twinkle, the feedback link is in the chat window. I hope you have received the same. Shivram Meena sir, I hope you have filled your feedback form, because until and unless you fill your feedback form, we will not be able to help you with the certificate of participation. The feedback link has been shared in the chat window, dear participants. So kindly refresh your chat window. The feedback link is there in the chat window, dear participants. Kindly just click on this link. Do not copy this link anywhere, because in that situation, you may copy some garbled characters, etc. So just click on this link and you will be redirected to the feedback form. Fill in your details carefully, because any mistakes that you make, they will directly go into your certificate. And then you will not be allowed to fill the form again. Shubha Jain ma'am, just before your message, I have shared the feedback link in the chat window itself. So you can even click on my name in the chat window. You will be able to see the feedback form link. I can see my number of participants has considerably reduced. So I assume everybody has already successfully filled their feedback form. This feedback form link is only active till 8:30 p.m. So please fill and submit the feedback form timely to generate your certificate of participation. My 37 participants are only left. So I assume all these participants have also filled their feedback form and submitted it successfully. 70799, that is a participant. We have Amit, we have Anupam, Bala Bhaskar, Bhargavi, Boya Seva, Dhruv Bhardwaj, Dr. Kudappa, Dr. R. Natarajan, Dr. Shishir Dikshit, Dr. Shiva Prakash, Dr. Shushma, Kulanthavil Ji, Lalita, Mohit Aneja, Namita Agarwal, Pankaj Sarma, Prin Dr. Ramchandran, Professor S.K. Mutto, Professor Ajay Kumar, Rajat Agarwal, Rajveer, Ratish, Rominder, Sanjay Behel, Sanjay Tyagi, Selvam, Shivram Meena, Twinkle, Vaibhav, V.N. Chaudhary. So I hope all these participants have already filled their feedback form and they are only awaiting their certificates. So last 27 participants are there. I hope all of you have received your certificates. In case yes, dear participants, you're most welcome to leave the meeting room. We'll meet you all on 4th of December. Thank you, Twinkle. You're most welcome to leave the meeting room. Take care and have a safe stay. Manish sir, I think we can start calculating whose feedback form we have not received. Thank you, Namita Agarwal ma'am. I repeat again, the feedback form link is only active till 8:30. So, dear participants, kindly ensure that you have filled the feedback form. Sure, Namita ma'am, you are most welcome to attend all our sessions. And with your blessings, we shall be planning many in the future. Bhargavi, please fill the feedback form. We have not received your form as yet. Last 20 participants are left. I hope all of you have successfully filled your feedback form. 70799, Amit Udawat, Bhargavi. Bhargavi, your feedback form is awaited. Boya Siva, Dr. Kudappa, Dr. R. Natarajan, Dr. Shishir Dikshit, Dr. Shiva Prakash, Dr. Sushma, Pankaj Sarma, Dr. Ramchandran, Professor Ajay Kumar, Rajveer Singh, Ratish Kumar, Ruminder, Sanjay Behel, Sanjay Tyagi, Vaibhav, and V.N. Chaudhary. Shishir, please fill the feedback form. Bhargavi and Shishir, your feedback forms are awaited. Please fill the feedback form, Dr. Shishir Dikshit and Bhargavi. Last 18 participants are left, out of which Bhargavi and Shishir, your feedback forms are awaited. @Shiva Prakash, please fill the feedback form. Your feedback form is also awaited. So Bhargavi, Dr. Shishir, and Dr. Shiva Prakash, please fill your feedback forms. The feedback form link is only active till 8:30 p.m. So kindly fill the feedback form so that your certificates can be timely generated. I repeat, Bhargavi, Shishir, and Shiva Prakash. Dr. Pankaj Sharma, please fill the feedback form. Dr. Shushma. So Bhargavi, Dr. Shishir, Dr. Shiva Prakash, Dr. Shushma, and Pankaj Sharma. Please fill the feedback forms. Otherwise, your certificates will not be generated. Rominder, kindly fill your feedback form. We haven't received your feedback form as yet. So Bhargavi, Dr. Shishir, Dr. Shiva Prakash, Pankaj Sarma, and Rominder, kindly fill your feedback forms. Dr. Ramchandra, your feedback form is also awaited. Rest all participants, I hope they have received their certificate of participation. Thank you so much for being with us. You may now leave the meeting room. I repeat, dear participants, this feedback form link is only activated till 8:30 p.m. After which the link automatically gets deactivated. So we'll not be able to help you with your certificate of participation. So kindly submit the feedback form as early as possible. Dear participants, if you are still there with us, I'll repeat the names for participants whose feedback form is still awaited. Bhargavi, Dr. Shishir Dikshit, Dr. Shiva Prakash, Pankaj Sarma, Rajveer, and Dr. Ramchandra. Sorry, Rominder and Dr. Ramchandra. Rest all participants, I hope you have successfully received your certificates. So thank you so much. You may leave the meeting room now. Dear participants, I hope everybody has submitted the feedback form successfully so that your certificates can be generated. We will be closing this room in another 5 minutes. So please, anybody who is still left with filling the feedback form, kindly fill it. We will be closing the room at 8, dear participants. So anybody who is still unable to fill the feedback form, I hope you may kindly fill it. The form link is active only till 8:30 p.m., after which the link gets deactivated. So we will be unable to help you with your certificate of participation. Dear participants, thank you so much for being part of this webinar. This is the last call for any participant who is still there with us and has not filled their feedback form. The feedback form link is active only till 8:30 p.m. So if possible, kindly fill the feedback form and generate your certificate. Over 200 certificates of participation have already been successfully generated. So with this, we come to end to this beautiful webinar today on Industry 4.0 Trends and Challenges. Thank you, dear participants, for being part of this webinar. Join us back again on 4th of December with our next webinar in the series. So thank you, dear participants. Manish sir, I think we can now close the room. Good night, sir. Good night, Manish sir.
Good night to all of you. Let's close it.
Yes, sir.